Yes, so I'm going to be talking a bit about the software development we're doing in Darwin EU. And my name's Ed Byrne, and I'm here at the University of Oxford. So just to say first that this presentation doesn't reflect the views of the European Medicines Agency, and it's actually not even really reflective necessarily of everybody in Darwin EU. This is a presentation I've made, so these are my opinions, and hopefully some might be strong, but hopefully weakly held. So yeah, that's just something to say at the start. So I'm just going to give a bit of an overview of the project, and then I'll go into more about what we've been doing so far. So this is the Darwin EU project that maybe people, I imagine quite a few people will have heard of already. But just to give some background, we have a central coordinating centre that's led by Erasmus in Rotterdam, and we're working with the European Medicines Agency. So the way this works is that the European Medicines Agency are providing questions, and then the coordinating centre is providing the tools and the software and running network studies, bringing back that results, putting it back together, and answering the EMA's questions. So actually, even when the tender was released by the EMA, they had this desire for data staying local and the use of the common data model. And yeah, so that was very much aligned with kind of the OMOP CDM and the way OHDSI have been working for many years. So in terms of the studies we do, kind of three core types of studies. So we have off-the-shelf studies. So these are where you can think of them often as descriptive epidemiology. So we might be estimating the prevalence of a disease, the incidence of a drug, the characteristics of people, and so on. We also have complex studies, where these are kind of more advanced statistical analyses. And then we have a small number of very complex studies. We then have another bucket, which are routine repeated analyses, where it's going to be the repetition of a study over time. So this is where we are. The dotted line is where we are at the moment. So we're currently in year 2 of the project. So in the first year, there were 4 studies commissioned, and this year there will be 16. And then in the next years, it's really ramping up. And in year 4, we can see 60 routine repeated, 60 off the shelf, 24 complex, and at least 1 very complex. So there's been a previous presentation by Peter at an OHDSI call. So I just put a link to the YouTube of that. And we also have a website now. So there's a lot more information than I've just given on the project itself. But yeah, I just wanted to really emphasize the scale of this project. So this is creating the potential to run 145 network studies in 2025. So this is all kind of building upon the foundations that OHDSI have laid in terms of the OMOP common data model and many of the tools. And OHDSI has been obviously hugely successful. There's been many impactful network studies, and I myself have been on network studies and been involved in them, and they've been successful. But I think everybody that's done them has agreed that they're hard. And so this is maybe the current situation as it is that there's this foundation of tools and software and the common data model and the network with the ability to run network studies, but that these network studies are difficult to do for various reasons. And many of them very difficult, I would imagine, to surmount outside of a project like Darwin EU. But in Darwin EU, we do have some benefits that can help us. But nevertheless, we share this similar problem that network studies are difficult. So that's the background of the project and where we are. And this is really personally how I think about things. So what we're doing in terms of the development side, and very much I'm talking actually about a narrow slice of the development side, which is mainly focused on our packages, but we're making the tools for the researchers in Darwin EU to deliver the studies that are commissioned by the EMA. So I like this quote about any tool being useful in the expected way, but the great ones being lending themselves to uses that were not expected, not foreseen by the developer. And another way I think is just to say this is just in the development idea, expecting the output of every program to become the input to another as yet unknown program, which is similar lines as we don't always know how these individual components will be used, but the ability of the users to put them together into the ways that satisfies their needs is often quite amazing. So coming back to those studies, we can think of those tools being used for off-the-shelf studies. So these are kind of the descriptive epidemiology I was talking about before. But we can also think about these tools being used in the complex studies where we go beyond the simple, and then even in the very complex. And I suppose like my way of seeing this of what we're doing at the moment and how we've built things is that this is very much like a low code, not no code solution. So the focus today has been developing our packages, which we can think of as our tools, and which Berta will speak about one after this about the incidence prevalence package, with users interacting with those R packages to prepare their analysis scripts and in a way that satisfies their needs. And I think one key thing for me always is flexibility for the users in terms of that they can use the tools we provide. They can also obviously use the tools built by OHDSI, but also the numerous other R packages out there on CRAN. So there's a huge number of things that have been made open source and that can benefit us. And it's really providing tools that assist users into getting what they need. And so one of the ways that drives this way of thinking for me is treating the users as co-developers. And I think this is really key. And one aspect where we are so fortunate in Darwin EU is that we sit side by side with our users. So those are the people running the analysis, writing the reports for the EMA. So, and this is just to underline that like the biggest risk of any software is that you end up building something that isn't useful, right? And the best way to avoid this is getting things in front of real users and getting their feedback about how valuable what we're developing is. And then some more quotes just like the other benefit for me personally is treating users as co-developers actually speeds things up and helps us in terms of code improvement, making sure any bugs are found and fixed. And really it's just that listening to the customers, or in our place the users, helps us iterate and quickly improve any software that we've created. And really, like I was saying, these users are not hypothetical users in our mind. Often they're the people we sit next to. So I've just took a few photos of some of the people using the tools in practice. And these are epidemiologists and data scientists in general. So these are people familiar with preparing code for data analyses, but not necessarily coming from a background where they're familiar with the OMOP CDM or certain specific packages, but they have a fundamental understanding of what it is to work with data and prepare analysis code. And just some of those books might be the kind of books on their shelf that they're used to interacting with, and the language in which things were expressed. And really, that's knowing these people has really helped us to kind of aim for user-centered design. Maybe just an example of what this might look like in practice is just say when we've got our functions that people might use, it's really getting their feedback to the level of the argument names to make sure that they're intuitive for them. So this was just one GitHub issue I picked out that was asking about the user interface, whether it made sense to the people that were in the end hopefully going to be using the package. And so it was getting some feedback about whether the argument naming was intuitive or not, and were there any things that would be particularly unclear. Albert mentioned that there was one questionable one that I then explained, and then Maria came back with some more questions, and then we came to to a better name that was more intuitive for everyone, and that I don't think we hadn't thought of initially, but hopefully we landed on one that was far more intuitive to the user that would be using the software. And yeah, and then maybe another way that we have users contributing is not just raising GitHub issues and discussing software, but they're actually quite frequently able to make user contributions. So one thing we've done a lot is writing the underlying software in the R programming language, so that it's very familiar style of code to the style of code the users in the end will be familiar with. And just picking out a random couple of functions from a package, these functions are actually very similar to ones users might write. Users might develop themselves, and they'll be able to see what these mean. And this can lead to very nice things for me, which is having not only an issue sometimes, but a pull request to go on along with it, where somebody's improved something or found a bug and fixed it themselves. So just a few examples of users opening pull requests that we could quickly merge. So all of the project is also underlined by a need for code quality. One way we can think about how to make the software maintainable in the long term is writing it for software peer review. So I quite like this idea that the readability and maintainability of the code is supported by the review process, and really making a maintainable base of software means that other people can read and understand it and contribute to it. And there's various links here or images here that I've put, but I think the software engineering book at Google has a whole chapter, has a whole section dedicated to this. So as well as thinking about the code we're writing, we also need to think about many of the dependencies we use. So in R especially, you have this situation on the bottom left where dependencies pose a threat to the stability and viability of our applications, but they're also unavoidable if we want to do things that we're going to have dependencies, and it's really not a possibility to just say, oh, well, we won't have any. So on the extreme, we can think of them as an invitation for people to break our code. And in fact, there's this paper that was looking at most of the errors in our packages, and they were finding that most are actually caused by changes in the dependencies rather than errors in changes to the package themselves. So I think I saw Martin on the call. So one way that we're trying to kind of create this maintainable code base is using tools such as the one Martin's been developing and leading, which is the package reviewer package itself. And so just to give a quick demo of how this works, is that I pulled up one of our packages called Codeless Generator that we have on CRAN, and we can run Martin's tool against it. So the first thing it does is provide a map of the functions in the package. So we've both got the exported ones that a user might interact with, but also the non-exported ones underneath. And we can get a quick visualization of the complexity of the package and how things relate to each other. We can also see things about all the different functions, and we can think of different ways that we might measure what it means so that something becomes less maintainable. Some things we can think about are number of arguments to a function, lines of code in a function, cyclomatic complexity as well. And in this specific package that I'm showing, we have, in general, relatively low numbers of arguments, kind of a medium level of lines of code, but one noticeable one with both higher number of arguments, higher lines of code and higher complexity. And we can actually see that this is one of the specific functions in the package. So this is actually extremely helpful when we think about refactoring the code, that we can concentrate our effort predominantly on that initially, if in terms of improving that, splitting it into a smaller set of functions that will make this package easier to maintain in the long term. And we can we can kind of get this summary, and it's unsurprising that these different measures of complexity lead to the similar conclusion that there was this one particular function that could be looked at in terms of improvements. So as well as that, we can look at the dependencies being used in packages. So here we can see all the different functions being called and from the different packages being used, and this again helps to kind of understand how the package is being put together, and really see that we can think about code smells and so on, but this is just a slightly more systematic way to review the current state of a package and what it's depending on and so on. And we can also see from this quite quickly whether there's some dependencies that don't need to be there, or some inconsistency where we're using similar functions from different packages and so on. And then one thing we're especially thinking about nowadays is the need for benchmarking. So this is being led by Cesar at Erasmus, actually. And this idea of benchmarking the performance of code is not particularly new. And this is present in many different domains. And really, I think the idea is that with the packages as we develop them, more and more we'll be trying to really benchmark their performance and make sure that the performance is kind of suitable to the task at hand. But then with all of this, there is this Goodhart's law to keep in mind, which is always being somewhat careful when you measure too many things, which is we can often make targets which stop them being a good measure in themselves. So this is something we try to keep in mind in terms of there might be good reasons some things are complex, some things are just inherently complex problems to solve, but where we can simplify things and make them more maintainable and so on, hopefully like lots of the tools lots of the foundations of what we do will help for that. And then just lastly, just to talk about like making progress, how we're going about that. So I think one thing I found hard to believe, but it's hard to avoid bumping into it more and more, is Conway's law, which is that any organization that designs a system will produce a design whose structure is a copy of that organization's communication structure, which I found personally to be very, very, very true of the way software often mirrors the organization that's been producing it. And I think just a good reference that I found very useful in terms of shaping some of my thinking, at least, was the Team Topologies book about how we can think of different teams and their different interactions, and how those teams and those interactions can work together. And then really what we're trying to do in Darwin is have high performing teams, right? So there's a nice book called Accelerate. So just two small takeaways from that is the need to build quality in, and that's really building a culture supported by tools and people. So if we think of the tool by Martin, that actually really helps us build quality in as we're developing packages, as we're getting ready to submit them to CRAN, we can really be aware of the quality of what we're producing. And also the ability to detect issues quickly, that they can be fixed straight away at the point and at the moment where it's cheap to detect and resolve them. And also the importance of working in small batches and decomposing features into small units of work that allow for rapid development, instead of having the need for complex features, the desire to create complex features, which can lead to kind of long living branches and slow release cycles. And I found, so there's plenty of metrics you can find to think about teams and so on. There's Adora metrics, but these linear, I think it's called linear B metrics, I also found quite interesting to think about what does it mean to be kind of a good performing team in this domain. And there's various ways that maybe sometimes like the problem we face might be very different to other software companies, but one I really would pick out for what I think about with what we're doing is just the time from when a pull request is created to when the review begins, because I find that being a very good measure of developer experience in terms of if people are contributing code, or at least trying to contribute code, how long does it take for that to be triaged? That I find is a very good indicator of whether the state of the package and whether things are going to be, it's going to be basically a nice experience for developers to work on and contribute to that package. So, and then just in quick summary before handing over to Berta, we've got various R packages on CRAN already that I've just put a few links to some of them here. And really, I think just to underline, like, that the tools we've been developing have been driven by the needs of our users who are delivering studies to the EMA. And obviously with the OMOP Common Data Model, we're very fortunate that external users with a similar profile can also find value for them and can install them from CRAN, which I think really makes the lives of users easy, and also has this big benefit for us in that there's this barrier to entry on CRAN that in some respects for some certain things can be very difficult to overcome, but for some other R packages can be overcome and can then help the maintenance of that package that barrier has been overcome. And then all of these can be seen to complement hopefully existing Odyssey tools, of which there's many extremely useful tools out there. And I think, yeah, maybe I just saw this quote as also, I think especially when we hear about Julia later, I think it's really something that I think about, is that really the need for diversity and not trying to find the one true way that satisfies every potential user, but really finding that for us ourselves, we can see that the software we've been developing has been done in collaboration and very much in mind of our users, but that a different set of users might have very different needs and requirements. So that's where that diversity of different packages, different ways of doing things can be so beneficial. I think that was the end of my slides.
Great, thanks, Ed. Oh, that was awesome. Okay, so Berta, you're up to talk about incidence prevalence, one of the Darwin R packages.
Yes, thanks, Adam, for the invitation. Let me share my screen. Okay, so my name is Berta Raventós. I'm a predoctoral researcher at the Jordi in Barcelona, and I'm going to talk about the incidence prevalence package. What I'm going to show today is the result of a very big team effort led by Ed. These are the main authors of the package, but there have been many developers and many researchers who have provided very useful feedback to the package. So these are the contents that I'm going to try to cover. So let's start by the objective of the package, which is to support analysis of population level incidence and prevalence rates in datasets mapped to the OMOP Common Data Model. We tried to develop a package which was flexible enough to accommodate EMI requirements for Darwin, but also a package that could be very useful for other studies and for other users using the OMOP CDM. So for the users, using the package has two main steps. The first step is to identify a study population of interest, that is what we call the denominator population, and then the user has to calculate incidence and prevalence within this population. So in order to identify this denominator population, the user can specify the study period in which he is interested in, but also the prior history requirements and the age and sex restrictions that he wants to add. So individuals are going to be able to enter this denominator population once they fulfill all the specified criteria, and they are going to exit the denominator population once any of these criteria is no longer fulfilled. So we can use the package to identify a population within the whole database, but we can also restrict this denominator population to a particular subgroup of interest. So maybe people who are taking a particular medication or who have a particular condition. And if we want to do this, we have to also consider the start and end date of these cohorts that we call strata. So in terms of incidence, one of the main important parameters is the washout. The washout is the period of time we use in order to exclude participants that had an outcome in the past, so before contributing time to the study. This can go from 0 to all prior history, but in certain cases, users might want to specify a certain amount of time, a certain amount of days, in order to establish this washout. If this happens after each event, we have to wait for this certain amount of time in order to include back the participant and in order to him contribute time again to the study. And we can also focus in the first event that occurs within the study period, but also in all the events that happen in this period of time. So individuals might be allowed to have multiple events in this study period. If we consider this option, we will have to apply this washout every day at the end of every event. So for prevalence, users will have the option to calculate point prevalence, which is the proportion of people who have the health event we are interested in a given time point, or period prevalence, which is basically the same, but instead of considering a time point, we can consider a whole period, which can be weeks, months, quarters, or years. And then in terms of the interface, we wanted to do an interface that was very easy to use for the users. So I'm going to briefly show how it looks like. The package works with CDM connector that generates a CDM reference to connect to the database. Here, just to show an example, we use a function within the package called mock incidence prevalence ref that generates an example of this CDM reference. In order to identify this denominator population, we can run the function generateDenominatorCohortSet. And for example, here, because we're not restricting our population with any kind of sex or age criteria, the population that we are going to identify is basically the whole individuals that are registered in our database. And as you can see, the denominator is created within the CDM reference object. And the format of the cohort is the same that we use for OHDSI in the OHDSI format. So if we want to add these restrictions, we can specify them with these parameters. So we can specify the study period, the age groups, the sex, and prior history requirements. And for every one of these combinations of these parameters, we're going to have a different denominator. All of them are going to be registered in the same table with a different cohort definition ID. We can also, as I said before, restrict our denominator population to people who have a certain characteristic. And in order to do that, we have to create a cohort with the individuals that we want to subset, and then instantiate this table into the server and create a table in the CDM reference. And then when we run this function, we have to specify the table, the strata table we're going to use for our analysis. It happens the same with the outcome. Once we have this denominator population identified and we want to actually compute incidence and prevalence, we have to point out the table in which we have the cohort, the outcome cohort in the CDM. So outcome cohorts have to be defined and instantiated before running the package. And actually, it's very important how these outcome cohorts are defined, because the definition can have like sizable impacts on the analysis. So for incidence, we can use the function called estimate incidence. As you can see, we specify the CDM object and then the tables we want to use, so the denominator and the outcome table. We can also specify the time interval we want to use, the outcome washout, and whether if we want to consider repeated events or not. The output for this function is a table that contains a row for each one of the time intervals and denominator and outcome cohorts considered. So as I said before, the denominator table might have multiple denominators, and it happens the same for the outcome. We can have multiple outcomes in a same table. In addition, this output has two additional attributes. One of them is the settings. Here we can easily identify all the settings and parameters used for every analysis. And the other one is the attrition. And here we can see the number of people who are being excluded in every step of the analysis. So for example, if we decide to restrict our population to females, we can see how many males were excluded. And lastly, we can add this last line in our function called return participants. And by doing this, we can generate a table with all of the participants that contribute time to our study. And this is important because the denominator function gives us also information about the potential participants, but depending on certain criteria, for example, the washout that we apply, this population might be slightly different. And we have two further functions, one for point prevalence and the other for period prevalence. They look very similar. So as before, we have to specify the CDM reference and the denominator and outcome tables, the intervals we want to use, and then we have an additional parameter called time point, which help us to define in which time point we want to calculate this point prevalence, so the start, the middle, or the end of the year. And for period prevalence, it's basically the same, but in this case, we have this full contribution parameter, which allows us to decide if we want to include these individuals that are not observed through the whole interval. So in this case, the whole month. Also, these functions, these functions have the same attributes and the same output format than the incidence prevalence. I'm not going to go through other functions now because of the time, but we have other functions to gather the results and export all the results in a zip file. So in terms of unit testing, we tried to develop a test-driven approach in which we were testing a lot the code we were developing. In order to test our code, we generated this function called mock incidence prevalence rect, which give us mock data to actually test the package. The tests were developed using the test.r package, and we developed tests in order to test the output format of the results. We did also logical tests, and we test edge cases to make sure they were well handled. And we added informative message in the expected errors. So in total, we wrote more than 500 tests. So we had more code for the test than for the actual package, and the coverage was high. So besides testing the package internally, we also performed different validation studies, and this was just to make sure that the estimates we were generating were accurate. And to do that, we compared the package results with those previously published. So we did 3 different validation studies using data from CPRD Aurum, CPRD Gold, IPSI, and CDApp. For the first study, we ran the package against CDApp and CPRD Aurum, and we calculated the incident rates of COVID-19, and we compared those rates to those reported in official government COVID-19 websites. And these are the results we got. As you can see at the beginning of the pandemic, we saw that the package results were actually higher than those reported in public websites. But this was basically because of the definitions we were using, because in our package, we were using a definition that not only included positive tests, but also clinical diagnosis. And these were not widely available during the first months of the pandemic. And this explains this huge gap. But as you can see, after the 6 months of the pandemic, the rates were very, very similar. In the second validation study, we tried to replicate a study looking at the background incident rates of adverse events of special interest for COVID-19 vaccines. This was a network study. We only used data from CPRD Gold, but we tried to replicate all the same settings that they used in that analysis. And this is the results we got. So we got high agreement between the results obtained with the package to those previously published in all the stratas and all the outcomes studied. And lastly, we replicated a drug utilization study of ranitidine using data from IPSI. And the results also show high agreement between those reported in the package and those previously published. And lastly, we did a benchmark analysis to assess the running times of the package, especially over the different tasks. So not only identifying the denominator, but also calculating prevalence in a month or yearly basis, and the same for incidence. And to do that, we use a function called benchmark incidence prevalence, which allows us to assess the time required to do a given analysis with a simulated outcome. You can specify the prevalence of that outcome. In our case, we use 4 age groups and 2 sex stratification, and a simulated outcome with a 100% prevalence. And we ran this function against the 4 databases that were used for the validation studies, and we computed this running time. The median running time was almost 40 minutes across databases, but as you can see, execution times relied on the size of the database, but also on the environment. And lastly, say that, as Ed already mentioned, the package is available on CRAN. However, the version that we have at the moment is preliminary. So we are still adding some more changes, some more features. In the future, we want to be able to add other functionalities, for example, to be able to exclude participants in incidents based in a different definition than the one that is used for the outcome. And we also want to be able to add a functionality to compare incident rates and to calculate incident rate ratios. However, you can already use the package. There is a lot of documentation in CRAN and also in the Darwin website. And all the things that I try to cover today in my presentation are also going to be explained in more detail in a paper. We are planning to submit it very soon, so stay tuned for that. And this is the team that contributed, well, part of the team that contributed to the package and to the study. So thanks a lot.